Hello engineers, welcome back. In this video, we're going to solve another Leet code question based on bitwise operators. Okay, let's get started. This is the question we're going to solve today. It is called find the original array of prefix XOR. Okay, so let's try to understand the question and then we'll see a solution. Okay, so you're given an integer array pref of size n. Find and return the array ARR of size n. So we have an array pref of a given size and we need to build a new array of the same size and return it. And this array should satisfy this condition. Pref of I equal to array of 0 XOR, array of 1 XOR, all the way up to array of I. Okay, this symbol denotes the bitwise XOR operation. It can be proven that the answer is unique. Okay, so let's try to understand this with an example. Let's take this to our whiteboard. Let's make it slightly bigger. Okay, so the concept is like this. So this is the main array 52031 and we need to build this array 57232. So how do we build this? So we can see here the first element is straightforward, which is the main array element itself, pref of 0. So we'll just copy it here. And for the next element, we have a condition. So condition is 5 or 7 should equal to 2. So what is 2 here? 2 is the element in the main array and we need to do a XOR operation on the previous element in the resulting array and find out this value so that it equates to 2. So 5 XOR something should equate to 2. And if we find this x, we can push this x into the resulting array. Okay. So how do we find this? So to find this, we can use the associative property of XOR operator. So let's say 5 XOR 7 is 2. This can also be written as 5 XOR 2 equal to 7. Okay, so this is the associative property of the XOR operator. So we can verify this. So what is the binary of 5? 0, 1, 0, 1. What is the binary of 7? 0, 1, 1, 1. And if we do XOR on both these items, so we get, we need variety for XOR. So there's no variety here. So this is 0, there's variety here, this is 1, no variety, no variety. So this is 2. So we have satisfied this condition. Now let's see this equation. So the binary of 5 is 0, 1, 0, 1 and the binary of 2 is 0, 0, 1, 0. And if we do a XOR operation, we get 1, 1, 1, 0. And this is 7. So we got 7. So we can use this property of XOR to find out x. So how do we get x here? So if we want x, we can simply do 5 XOR 2. And 5 XOR 2 will give us x. Okay, that way we know how to find x. Now we simply need to push it to the resulting array. Okay, now let's see the next element, pref of 2. So what is pref of 2? They are saying this is the equation 5 XOR 7 XOR 2 equal to 0. So the equation is 5 XOR 7 XOR something should equal to 2. If we find this something, we can push it back to the resulting array. Okay, but we already know the answer to this now. 5 XOR 7 is 2. So this equation becomes 2 XOR y equal to 2. Right? Now we simply need to find y. So what is y? We can use the same property again. So we simply say 2 XOR 2 equal to y. And 2 XOR 2 is 2. So we'll push the value 2 here. And this will go on. So pref of 3 is XOR of the previous elements. And we need to find this new element, which will equate to 3. 3 is coming from the main array. And for pref of 4, we need to do XOR of all these 4 elements. And we need to find this mysterious element to get the value 1. So 1 is coming from the main array. Okay. So we can see that we are kind of doing repetitive XOR. We have done 5 XOR 7 here. Again, we are doing 5 XOR 7 here with some other element. And we are doing 5 XOR 7 XOR 2 again with some other element. and we are repeating the process. So there are repetitive XOR operations. So we can try and think of a technique like a prefix sum in order to avoid all this. Okay. So let's see how we can code this. Now we know how to find the answer of these x, y, z elements. We simply use the associative property of XOR. So let's code it. So what do we need? We need one vector, which is our resultant vector. This will be ARR. And the first element of this vector is straightforward, which is the main element, first element from the main array. So we can simply do pushback, and we can do pref of 0. So the first element is done. And we also need another vector to keep track of the XORs. So we can call it XORs. And the first element of this vector is also straightforward. We can do pushback, pref of 0. And how will we use this? Let's say this is my ARR and this is my XORs vector. So first element is done, which is 5 here and 5 here. Whenever there is a new element in this array, in this vector, let's say my next element is 7, I will do a XOR of these two, and whatever is the result, I will store it here. And when there is a third element, which is 2, whatever is the XOR of all these three, I will store it here. And I will continue to fill this array. Okay. So in order to get the XOR of all these three, I don't need to recalculate again because I have the XOR of first two elements already available here. I will simply do a XOR of 2 with the new element, XOR of 2. And whatever is the result, I will store it here. And when there is a fourth element, which is 3, I already know the answer of XOR of all these three. Now I simply need to do a new XOR with the new element. Whatever is the result, I will save it here and so on. So that will be the logic. We do this so that we don't have to recalculate XOR at every stage for every element, right? So let's continue. So we will iterate over the main vector now. We can start at 1 because we already done 0. I less than pref dot size and I plus plus. So what do we need? So we need to calculate the XOR up to this point, which is stored here. So the definition of this is XOR up to I. So now I am at I equal to 1. So the XOR up to I will be available in the previous element, which is I minus 1, which is XORs of I minus 1. XORs of I minus 1. And I simply need to do XOR with the main vector new element. Why? Because we saw this associative property, right? If I want to get the x value, I can do a XOR with the RHS value to get the x value. Now RHS value is available in the main array. So this is available in pref of I. This is the new element. And we will store it in a result. So we have found our result. We simply need to push it back to this one array. So ARR dot pushback result. What did we say before? Whenever there is a new element in the ARR vector, we recalculate the XORs up to that point and push it to this fellow. So XORs dot pushback will be the XOR of the new element. The new element is available in result, and we can use the XORs of I minus 1, which is having the value of all the XORs up to that point. And then we are doing a XOR with the new element, and then we'll push it. And that's it. That is our code. and we simply return our resulting vector, which is ARR. Okay, so if we don't use the XORs, we can do something different with a nested loop. We can probably use inner loop, let's say for j equal to 0, j less than ARR dot size j plus plus, and we calculate XOR. Let's say we have a XOR variable here. We simply do XOR of this with ARR of j, something like this, and we get the resulting XOR up to that point here. So let's say my I is here. I can get the XOR value for all these three elements within this nested for loop, and then I can simply do a XOR with the pref. But this is nested operation, which is increasing our time complexity. So in order to reduce that, we use an additional XOR vector, which will keep track of the XOR calculations up to that point. So we can save some time complexity. Okay, so that is our code. So let's code it on Leet code. So what do we need? We need a resultant vector, which is ARR. We need another vector, which is XORs. So the first values of these two will be same. Pushback ref of 0, XORs dot pushback ref of 0. So the first elements are done. Now we can start the for loop for the rest of the elements. Ref dot size I plus plus. Now here we are calculating the result, which is available as a XOR operations up to that point. Now XOR values up to that point is available in I minus 1, the previous XOR element. Now we need to do a XOR with the new element from the pref vector. So this will give us the mysterious element x. Now we simply need to push it. Result. And whenever there is a new element in the array vector, we need to recalculate. So we need to do a new XOR with the new element with the result up to that point. Up to that point, results are available in XOR of I minus 1. And that's it. The loop will continue. We will have filled our array. So we simply return ARR. So the code is simple once you have the intuition in hand. So let's run it and see. So this is accepted. We can submit. And it is accepted. So we have used two techniques in this question. One is bitwise operators, obviously, because we are dealing with XORs. Another is the concept of prefix sum. So this vector XORs is helping us to pre-calculate and save the XOR values up to that point. We have seen this technique in prefix sum, where we are saving the sum values up to that point in a new vector. So that same concept is applied here. So we have combined those two techniques and we got our optimal solution. Okay, so the time complexity is O of n because we have iterated over this array, but space complexity is also O of n because we have used additional space. Okay, so that's how that is. So if you have any questions, you can definitely ask me. Thank you so much for watching, guys. Please don't forget to like the video if you found the solution helpful. And if you have any questions, you can ask me. Please bookmark the playlist. Please subscribe to the channel if you haven't done already, so that you don't miss out on the next videos. And do leave a comment if you have anything to say. And I will see you in the next one. Thank you. Cheers.